Hello and welcome to C# 101 Week 3 with me, Nelson, as your lead instructor. So today what we're going to do is we're going to first of all wrap up the homework from last week. I'm going to go ahead and write out how I would have approached the problem given what we've already taught, and we'll talk about that for a couple minutes. Then we will move on to what we were going to do last week with arrays, so that's going to be lots of fun. And then we're going to get into lists, for loops, for each loops, and switch statements. So there's not a whole lot of new syntax to talk about today, but there's a lot of very important theory to understand about how arrays and collections work, because they allow us to do things that aren't actually possible yet with what we've learned already. So I'm going to start off again, like I said, with the homework, if I can get my Visual Studio window open. And let's go ahead and do some stuff. So first of all, I'm going to start off the program with using system. I know that my program is going to be using quite a few classes from the system namespace, so I'll just put that up there preemptively. All programs in C# or all code in C# has to be in a type of some kind, such as a class. You cannot have floating functions or variables or anything like that like you can in other languages. Then I'm going to have a public static void main, which again is going to be the entry point to our application. So the first goal of this program is to identify how much money the user currently has. So I'm going to start off accomplishing that goal first. So I'll do that by putting in a decimal money to represent how much money the user has, as well as a boolean indicating if they've entered their amount of money correctly. So has entered money. And we'll default this boolean to false. Next up, I'm going to enter a while loop while we have not entered money. I don't know if we talked about the not operator, but I can just toss that in right now. It's early in class. The not operator is this little exclamation point right here. It is the equivalent of saying if has entered money is false. It does the exact same thing. It's just a shorthand for doing that because it's so common. This is such a common pattern that we have a bit of syntax for it. So I'm going to say while we do not have our money entered, I'll prompt the user for their money. And then what I'm going to do is I'm going to enter in a, I'm going to say has entered money equals decimal.tryparse, passing in the result of console.readLine with an out parameter or an out argument of money. So that just says try to get the input from the console, stuff it into decimal. If you can do that, return true and stuff the result of the parsing into this money variable, otherwise return false. So then I can now say if not has entered money, which will happen if they've failed to enter a valid number, I can say console write line invalid input. So at this point, again, it's good to kind of get, or when you write your software, money won't be definitely assigned, unfortunately, even though statically you could prove that it would be definitely assigned. So I'm going to initialize money to 0. But anyway, it's good to write your programs in little steps. So we've accomplished our first goal, and I just tossed in a console write line down here just to make sure that I can actually run this program and it'll accomplish what I want it to. And we see that it does. So we've gotten through the first step. We have successfully received decimal input from the user. So that's nice. But next up, yes, while the while statement is a loop. This code will continue to execute until this condition is false. So until not has entered money is false, which is a double negative, kind of, then this code will continue to loop over and over and over again. I can prove that by just sitting here and giving it bogus input. You know, it'll sit there and wait for me to type in proper input, and then it'll finally exit the while loop. So next up, we have, I'll go ahead and print out how much money you have. I'll say console write line, you have. And then we'll enter the rest of the program. So the rest of the program was kind of a little vending machine that allows people to enter in a selection of items. And it'll continue to loop until they are out of money, or they're more specifically incapable of purchasing anything on the menu. So we'll start off with just saying while money is greater than 0. Now we're going to change that pretty soon here, because remember, I also want this while statement to end when the user doesn't have enough money to actually purchase anything. But for now, I'll just say while money equals 0. So now I have to print out my menu for the user. So I'll say console write line. What do we have here? Let's toss in a Coke for $3. I can't remember what I did last week. I'll just put in 3 selection. A Coke for $3, a Pepsi for $10, and a Mountain Dew for $100. And then I'll go ahead and prompt the user. So just this line right here, 28, will just provide a nice little prompt for the user in the console. So now I have to receive input from the user, and I have to make sure that A, it's a valid number that they've typed in, and B, it's within the numbers 1, 2, or 3, because if it's not within 1, 2, or 3, it's not an actual product that we have to sell. Also at this point, now that I have my menu written out, I can actually alter my while loop and say, well, it's not that while money is greater than 0, because what if we only had $1 left? If we got $1 left, we'll be stuck in this while loop forever, because no product is going to be able to be purchased for $1. So instead what I'm going to do is I'm going to say while money is greater than 3, because right now that's the least expensive item on the menu. So at this point I have to receive input from the user. So I'm going to create an integer up here called menu choice up at the top of my method, and I'm going to then say if int.parse or int.tryParse console.readLine, comma, out choice, menu choice. If we get into this if statement, we know that they entered a valid number. If we did not, we know that they did not enter a valid number, so I'm going to say if not, then console write line invalid input. Now the next check I have to perform is I have to see if their menu choice is within the values 1 through 3. So what I can, unfortunately we haven't really, actually no, I'll not worry about that validation at this point, because that's when things get interesting. Okay, so I'm not worrying about validating those 1 through 3 quite yet. I'll show you guys how we could do that after we review the homework. But so actually, yeah, this should be greater or equal than 3. But anyway, what we need to do now is we need to identify what they've chosen, 1 through 3, and we need to see if they have enough money to purchase the item. If they do, we subtract that money from their money and we present to the user what they purchased. Well, I saw a lot of people's homework and they approached the problem the way that I had expected people to have approached the problem. However, I'm going to show, based off the stuff we've already talked about, I'm going to show a very clean, a much cleaner way to implement this logic using variables, as opposed to littering all of our code with a bunch of console input and output. So I need 2 variables. I need decimal item price, and I'm going to initialize this to 0, and I'm going to do string item name, and I'm going to initialize this to an empty string. Then I'm going to do bool is valid item, and I'm going to initialize that to false. So I'm tossing up 3 more variables at the top of my method: item price, item name, and is valid item. Then what I'm going to do is inside of this if statement, I'm going to check to see if menu choice equals 1, that means they want a Coke. So let's set item price to 3, item name to Coke, and is valid item to true. If their menu choice is 2, let's set item price to 10, item name to Pepsi, and is valid item to true. If menu choice is 3, then item price becomes 100, item name equals Mountain Dew, and is valid item equals true. Now before all of these if statements, I want to reset is valid item to false. Now at the end of all these if statements, we now have code that sets these variables depending on their menu choice. And now what we can do is I can say if is valid item, then we enter the logic for detecting if they have enough money to purchase this item to begin with. This way we can have all of that logic be in a single place, as opposed to repeated for every single item choice that we have in our program. And again, this is all using techniques that we've already gone through, but it's approaching the problem in a much more abstract way than I expected most people to have approached the problem, which is why I actually chose this as the homework in particular, so I can show a use of variables to make our code a little bit more concise. So if it's a valid item, then we want to perform our logic to determine if they have enough money for it. Otherwise, we want to tell them console.writeLine menu choice is not a valid item. So inside the is valid item check, I first have to detect if they have enough money to buy this item. Yes, this is being recorded. Fortunately, I now have this item price variable that is full or set to whatever price of the item that they chose. So I can just say, in a very abstract way, if item price is greater than our money, then we cannot purchase this item because we don't have enough money. So what I'm going to do is I'm going to say console writeLine, you tried to purchase a item name, but you do not have enough money. Now, if we do have money, then this else statement gets hit, in which case we can go ahead and say, well, here we go, console writeLine, you purchased a item name for item price. And toss in a $sign there just to make that look a little pretty. Then after we tell them that they purchased the item, I can go ahead and say money minus equals item price. So I'm subtracting item price from how much money they have left over. The final thing that I want to do is at the top of this while loop, I want to tell them how much money that they currently have. So that'll make the program a little bit easier to work with for the user. So I can say you have, actually I'm just going to take this line of code right here and I'm going to dump it into the while loop. So every time the while loop executes, it'll say you have money. Finally, at the end of this program, we need to tell the user that they ran out of money and they can no longer purchase any item. So what I can do is say console writeLine, you no longer have enough money to purchase anything. I don't know anybody who would sit at a vending machine until they were broke, but that's what this program requires. So I'm going to go ahead and run the program, and I'll run through it one more time, and then we'll get moving on. So let's enter how much money I have. Let's say I have $5,000. And it says I have $5,000. Let's buy a Hello World. Oops, invalid input. Okay, let's buy a 5. Nope, 5 isn't a valid item. So let's buy a Coke. I purchased a Coke for $3, and my money was successfully reduced by how much a Coke is. So let's buy a Mountain Dew and another Mountain Dew. And okay, I have to buy a lot of Mountain Dews to get this money down to 0. So I'm going to close that out, open this back up again, and say, let's say we have $200. So let's buy a Mountain Dew. Now I have $100. Let's buy a Pepsi. I now have $90. Now let's try to buy Mountain Dew, and it says you tried to purchase a Mountain Dew, but you do not have enough money. And now it says you have $90. So now the only item I can purchase is a Pepsi. So if I go down to $10 by purchasing a bunch of Pepsis, I can now go and try to buy a Coke. It says you purchase a Coke for $3, you now have $7 left. If I try to buy a Pepsi or a Mountain Dew, it'll tell me I can't. All I can do is buy a Coke. So now I have $4, but watch what happens when I buy one more Coke. It says you purchase a Coke for $3, and now I no longer have enough money to purchase anything because I only have $1 left. So let's go ahead and run through the code again real fast. At the top of the code, top of the file, or top of the method rather, I have specified all of my variables I will be using for the rest of the program. I then enter a while loop. This while loop will continue to execute until the user has successfully typed in a decimal value. The reason it'll continue to execute until we have entered valid money is that this Boolean has entered money is being checked every time the while loop tries to execute. This expression right here again uses the unary not operator, and the unary not operator means that whatever Boolean it's attached to will be flipped. It is the exact same code as doing this. So if I said while it has entered money equals false, that's the same thing that doing that exclamation point will do. It's just a shorthand operator for flipping a Boolean. And you'll see me use it a lot. It's a very important operator. Next up, we have a console write that just says enter how much money you have, and then we say has entered money equals decimal try parse console read line out money. We've gone through this code quite a bit already because it does look a little bit scary with its out modifier right here. But again, the whole point of this line is to A, accept input from the user, try to parse it, return whether or not it was successful in parsing it, and if it was successful in parsing it, store the result in the money variable. So now we do another check for has entered money, and this does look kind of redundant for while not has entered money, if not has entered money. It's the same expression, but I use that just for the convenience of the user to actually tell them they've typed in invalid input. Because I know that if not has entered money is true, that means the loop is going to execute again and ask them for their money again, and again and again and again until they're capable of typing in a proper number. Which, believe me, some users are not capable of typing in numbers. So next up we have another while loop. Now this while loop is also interesting because it's not checking to see if we don't have any money left. It's checking to see if we have enough money to purchase the cheapest item on our menu. So this 3 value is not an arbitrary decision. This 3 value is there because the cheapest item on the menu is $3. So we want to say while the user has $3 or more in their money variable, then continue this loop. Once they run out of enough money to purchase anything on this menu, then the loop stops. So yeah. So once we enter this loop, we present them a menu. I mean, this is just straight up console writing stuff. It doesn't do anything magic behind the scenes. It's just writing text out to the console. But then things get interesting. And this is where, again, I wanted to show how to implement this in a more abstract way, because a lot of people's homework, and this is what I was expecting, had a bunch of validation checks repeated for every single menu choice. And I expected most people to do that. But now I hope you can see that what we can do instead is we can use variables to abstract away the concept of our logic of checking to see if they have enough money to do something. Because at this point we enter another int.tryparse. Now this int.tryparse doesn't store into a Boolean variable. Instead, it's directly inside of an if statement. Now that's completely valid. Anything that returns a Boolean can be put inside an if statement. So we can put int.tryparse console readline out menu choice. And again, this will return true if they followed instructions and typed in a number, and it'll return false if they did not type in a proper number. If it returns true, then our menu choice will be a variable that contains whatever choice that they selected. If it is false, then we will go to this else statement down here all the way at the bottom. We know that this if statement is paired with this else statement because it's on the same level of indentation. Now, that's not completely true from the language point of view. From the language point of view, the reason that this if statement is paired with this else statement is if I click right here on this little curly brace, you'll see that this curly brace down here is highlighted. That means that this curly brace is paired with this curly brace. But for readability to a human, it's very important that we have proper indentation so we can clearly see that this if statement is paired with this else statement. Because there's a bunch of other if and else statements here, and it might get confusing knowing which one is paired with which, but because we have indentation, we can easily see that. Now, if they did not enter a valid number, then we can go ahead and tell them that they've typed an invalid input. And then once we do that, we just continue the loop. Now watch what happens when I click on this curly brace. If I scroll all the way up, we'll see that the curly brace on the while loop is highlighted. That means if we hit this else statement, we'll write out some console output, we will end the if statement, then we'll end the while loop. And when a while loop ends, it jumps all the way to the top, checks the condition, and will execute again if the condition is true. Okay, now it gets to the scary stuff. So inside of our if statement, we have 4 other if statements, of course, and the first thing that we do is we set isValidItem to false. We want isValidItem to default to false at the top of this at all times. And what I want to do is I want to check to see, okay, if menu choice equals 1, store the item price, or store the value 3 inside of item price, store the value Coke, the string literal Coke inside of the variable item name, and change isValidItem to be equal to true. Then the next if statement does the same thing, except for it has different variables, or different values, sorry. So if they type in 2, then, well, we set the item price to 10, we set the item name to Pepsi, and we set isValidItem to true. If the menu choice is 3, then we set item price to 100, item name to Mountain Dew, and isValidItem to true. Isn't isValidItem false because that's what we defaulted to? Well, no. See how if we get into any of these if statements, if we detect that the user has entered 1, 2, or 3, we override the value of isValidItem to be true. And we use that variable in order to detect to see if they typed in 1, 2, or 3. So isValidItem will be set to true if they typed in 1, 2, or 3. And we can know that because these if statements set it right there and overwrite whatever existing value was inside of this variable to equal true. And we can use that then again to detect what we're going to do. So if they did enter a valid item, at this point our item price and item name are now equal to what we told them they would be based off the menu. So that's kind of nice. I'll go ahead and do the else statement first, then I'll get into this final if statement, or the second to final if statement. If they did not insert a valid item or type in a valid item, we tell them that it's not a valid item and we move on with our day. Again, if we hit this else block, execution will go down here, and then go down here. Once it goes down here, again, because this is a while loop, it jumps all the way back up to the while loop, and we continue on and on and on and on. So if they did type in a valid item, we check to see if the item price is greater than money, because if it is, that means they can't purchase that item. They don't have enough money. And if they don't have enough money, we tell them that they don't have enough money, and we, again, just go on our way. There's not much else our program can do. Otherwise, we tell them that they purchased an item name for item price. And then we subtract money by item price and store that result back into money. So pretty much everyone had something similar to this, but the biggest difference between what I have here and what most people wrote out is that I abstracted away the concept of having our item price check. A lot of people had multiple item price checks in every single if statement. And while that's perfectly fine and acceptable based off the prompt and what we've learned so far, a better way to do that is to only have that code written once. And that's what we did down here. And because we only want to write this code once, we have to think, well, what are the variables? If we were to have this code on every single one of these if statements, we would ask ourselves, what changes between this code and how can I abstract it away? And we would see that the only difference between our if statements being repeated 3 times and our if statements not being repeated 3 times is that the item price changes and the item name changes. So because of that, what we do is we turn these into variables and we have them set to their values depending on which choice the user made. And as a result, we get a working, albeit useless program. Finally, at the end of this while loop, once they no longer have enough money to purchase any item on the menu, we go down to the bottom, we tell them that they're broke, and then we put in a read key to pause the console from closing, and that's it. So, how's everyone doing for this overview of the homework? Alrighty, for people who have difficulty with this code, I guarantee you, and every programmer will tell you the exact same thing. If you have difficulty with code, the number one thing to do that will help you with it is to write it out. The act of typing out code and watching that output happen on your own computer and your own instance of Visual Studio or MonoDevelop or whatever is substantial and really helps solidify concepts like these. So write this code out. The video will be made available shortly after class, and you'll be able to go through and write it out. Even if you don't understand it, just do it character for character. You do that enough times and stuff starts kind of making sense. Stuff starts solidifying in your brain. Okay, I'll go ahead and leave this project intact and fire up another version or another instance of Visual Studio. And for people who missed week 2, unfortunately, that's when we went over what parse and try-parse do. That video is available for download. It's on the C# in the C# forums on 3D Buzz. So just review that if you're having difficulty understanding try-parse and parse, because those are explained in depth there. Okay, so arrays. This is going to be fun. So let's say that we wanted to write a program that printed out or allowed a user to type in 3 names, and then the program printed out those names in reverse order. I know this sounds very academic to people and kind of silly or useless, like, oh, what does storing 3 names have to do with making, explosions and spaceships and guns and stuff like that in Unity? Well, the same concepts do apply. It's just when we're stuck within the constraints of the console window, we don't have a lot of opportunity to make explosions and spaceships and guns. But bear in mind that despite the fact that this example will look very useless, just bear with me and take my word that is very important. very important for what I want to talk about. So based off what we've already learned about programming, we could accomplish this program pretty simply, actually. We can say string name1, string name2, string name3, and then I can say console.write enter name1, and then I can say name1 equals console.readLine. And then I can copy and paste this code because I don't want to type it every single time. And I can do name2, name3, and then remember what I wanted to do is I wanted to display these names back to the user in reverse order, which means I can now do console write line name3, name2, and name1, and then console read key. So now if I were to hit F5 and type in 3 names, I don't know, Nelson, Lakay, test, and hit enter, we get test, Lakay, Nelson. So our program does what we want it to do. It seems pretty straightforward. It doesn't do a lot of stuff, but it does have a very distinct problem with it, and something that you will run into throughout all programming. And that is, it's not very easy to change. If I wanted to add a name for example, I would have to create a variable up here. I would have to say console.write enter name4. Name4 equals console.readLine, then go all the way down here and say console write line name4. So that's a lot of code to add a very simple feature to the program. This pattern is very, very common in programming, where we have a lot of variables that share a type. Notice how these all share a type. They're all strings. They all contain text. But it's so common in programming that we have variables that share a type, and then we write code that's just repeats itself over and over and over again, with the only difference being what variable you're stuffing the value in. I mean, this happens so much in programming that there is a concept in programming, in virtually every programming language I've ever used, that allows us to do this in a very concise and abstract way that's very easy to change. And that's the concept of an array. So let's start off with let's try to implement this code with using a loop, but without using an array. Because I know I'm about to write out a bunch of really, really invalid C#, but the really, really invalid C# is the code that I've seen a lot of people write in the past. And it's kind of like what people naturally try to, when presented with a problem like this, that's what they end up typing out. And it's wrong, but it's kind of good to see what people, how people approach this problem without arrays. So what do I want to accomplish? Well, I want to create 2 loops here. I want to create a loop that receives all of the input. Then I want to create another loop that prints out all the output. So I want to replace all of this repetitive code with 2 loops, which is perfect because that's exactly what loops are for, is for replacing repetitive code. So I'm going to go ahead and say int name index equals 1 while name index is smaller than or equal to 4, console.write enter name index. And then what do we do here? Well, I'll get to that in a moment. Now we've replaced our enter name bit with kind of sort of a loop that will kind of sort of work, but it won't really, and we'll see why soon. Let's go ahead and replace our output loop with the same thing. Whoops, I forgot to actually there we go. I forgot to increment my variable every time, because otherwise this loop would sit there and say enter name1 forever because name index never changed. So I'll do that. So let's replace this group of write lines with the loop. So I'm going to say name index equals 4 while name index is greater to or equal to 1, console.writeLine, and then what goes into here? And then name index minus equals 1. Okay, that's good. We started off by taking repetitive code and turning it into loops. Yes, the code looks a little bit more complicated, but it's infinitely more flexible because now I could have 100 names or 200 names and I don't have to write 100 or 200 lines of code. But we have a problem. There's currently no way, based off what we've learned so far about programming, for us to access our name variables just by changing which one we're looking at with an integer that's run at runtime. So how could I go ahead and store a value of whatever the user typed in into one of these name variables when the name variable that I want to store it in changes every time the loop executes? The first time the loop executes, I want to store my value in name 1. The second time, I want to store it in name 2. The third time, I want to store it in name 3. And the last time, I want to store it in name 4. Well, we could certainly do something like this. If name index equals 1, name 1 equals console read line, blah, blah, blah. We could do that. This is one way that I've seen people approach this problem without arrays before, where they'll have unique variables for every single thing that they want to represent, and then they'll use an if statement or a switch statement to determine which variable they want to shove that data in. But now we're back to square one, where for every name that we want to be able to type into our program, we have to add more code, and that's not really acceptable. So what's the next solution? Well, some people try to do something like this. I've seen a lot of people do this, where they're like, okay, well, I wonder if I take the name variable and I concatenate on an index, and I use this expression to dynamically refer to one of these 4 variables. I've seen this written a lot, and it doesn't work. It won't work. It won't ever work. It's not how C# works. There's no way to dynamically access variables inside of C#. That's not true for all languages, but for C# it is. So this solution is out. There's no way to do it. So now we're back at a point where, well, what do? Our requirements are, we want to be able to uniquely identify one of these names inside of a loop, and the only thing we have to base it off of is a number that starts at 1 and ends at 4. Well, in programming, what we can use are called, well, arrays. I think I've pretty much alluded towards that throughout the last 20 minutes of discussion. So yeah, we need an array. And what is an array? Well, an array is a way to have multiple variables that can be accessed dynamically depending on an index. So what does that mean? Let's look at the syntax first. First of all, any type can look like an array, or can be an array in C#. Any type. In fact, arrays can be arrays if you wanted to go crazy, but we're not talking about that. The way to make an array is we have 2 steps. The first step is we have to declare it. And the second step is we have to instantiate it. So, a bunch of new crazy, scary syntax has just appeared on my screen. For the sake of clarity, I'm going to combine these 2 statements. However, just like with variables, you can split the declaration and definition, or you can combine them if you wanted to. I'm going to combine them for now, because there's a lot of scary syntax already going on. I don't want to confuse it with 2 lines of code. So what we have here is an example of an array, and there's 2 aspects to it that are very important. First of all, there's the type, or there's 3 aspects of it. First of all is the type. Now, an array type is any normal type plus these square brackets. That's it. To make a type an array type, all you do is add these little square brackets. Next bit of syntax is just like any other variable, because an array is going to be a variable. and that's not our identifier. In this case, I've named my array name array. Next up, though, we have to instantiate it. Now, this is where things get crazy, and the word instantiate is going to become very, very important next week and on week 6 especially. But keep in mind that when we see the new syntax, the new operator is what it's called. It's called an operator, just like the addition operator or the subtraction operator. The new operator is responsible for acquiring memory for our program. And what does that mean? Well, don't worry about it. All it means is that it makes arrays work. So to do this, we have to instantiate our array. So we say new string, then we have our square brackets, but right now we have something inside of our square brackets. So this won't work. You remember how I said that if you add the little empty square brackets next to a type, that turns it into an array type? That's true. But when you instantiate an array, you have to fill the square brackets with a number. That number can be pretty much anything that you want, as long as you have enough memory for it. And what it does is it tells you how many variables are going to be inside of this array. Now, I'm sure that I just completely freaked everyone out. What I'm going to do is I am going to complete this example using the name array. I'm going to write it out, and then we're going to take a break. When we come back, I'm going to jump into the whiteboard and talk about what exactly is going on. Because it might take a little bit for things to actually soak in if you're completely new to arrays. But for right now, I'll give you a basic overview of what I'm doing here. I'm creating 4 variables right here on line 7, just like how I created 4 variables right here on between lines 9 and 12. The difference is that the 4 variables inside of this array I can access dynamically based off of an index that I can calculate dynamically, which seems to be exactly what we need to make our program work. So I'm going to go ahead and remove these name definitions, and then I'm going to write my code in a way that will allow us to use this array. So enter name blah, I'm going to say name array at name index -1 equals console readline. If this totally freaks you out, especially like this and why I have to subtract 1, again, we're going to the whiteboard once we get back from break. I just want to toss some code up on the screen to let it kind of sit in your guys' minds for a few minutes. Next up, on my line 22, this is another instance where we didn't know what to put in here because we had no way of dynamically accessing one of our variables. So what we're going to do is we're going to say name array at name index -1. Now I'm going to write this program and enter name 1. That looks ugly. There we go. Enter name 1, Nelson Lekay test whoa. And we get whoa test Lekay Nelson, which is exactly what we want. So you might be saying, wow, this code looks a whole lot more complicated than what we had before, and it does the exact same thing. Well, watch this. By changing that value 4 to 6, by changing this 4 to 6, and by changing this 4 to 6, without changing any other code or even adding any code, I now have 6 names. So 6 names, what am I going to do? And we get it back in order, or in reverse order. And again, we did that all by changing this number. In fact, that number could be determined at runtime if we wanted to. So the point of arrays are, again, to be able to dynamically access variables and write code where we don't have to repeat ourselves over and over and over and over again. Alrighty, So again, I'm going to go ahead and leave this code up on the screen just for people to take a look at. If it doesn't make any sense to you at all, don't worry, because we're going to come back and whiteboard it out. But I wanted to give people an idea of what the syntax looked like first. So, alrighty, and we're back. So, I did introduce arrays. I hope that even people who still look at this code and have no idea what it's doing can at least see something going on here with this name array and how we can use it to contain more than one variable. But arrays are actually very easy to represent visually, and because we do have the technology, I'll go ahead and do that for you guys. So let me go ahead and bring over my tablet and watch everybody laugh at my absolutely horrid handwriting. So, whoa, hold on. There we go. Okay, so what we had first is we had a program that had 4 string variables. So we had Photoshop. I think Photoshop died on me. Yay. Give me a sec. Yeah, it stopped responding. Go away. We'll fire you up again. Sorry about that, guys. Had a little technical difficulty there. Hopefully now my tablet decided again to reset its display. And we need a brush, and we can now write with our brush. So that is good. It's really, really laggy, but that should be fine. Okay, so we started off our program with 4 variables. We had 4 strings. And we have one more. Okay, we've talked about variables to death. We've talked about how to use them, what they're useful for, blah, 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 how to assign values to them, and all that fun stuff. So hopefully these 4 definitions or declarations that I have right here of strings should be fairly straightforward. But what we oftentimes need to do is we need to write code that can store values inside of a variable in a dynamic way where the actual variable can change. Because we ran into a problem when we wanted to write our program in a way that used loops instead of repeating our code over and over and over again. So what we needed a way to do is we needed a way to have one variable that contains multiple variables. So that's what arrays allow us to do. So let's say that this string contained, hi. And this string contained, whoa, that's not even close to a W. That's closer, but still awful. And this string contained blah. It doesn't really matter what these strings contain. They contain something. So we have strings and they all have values in them. But what if we wanted to have a single variable that can contain multiple values? Because right now, what I just wrote out here is that each one of these variables only contain one value. They only contain one bit of text. But it's often very important to make sure that you're using the right brush type because that looks very blurry. I just realized. Because I'm using a soft round pressure size. Okay, hard round time. That should be better. Okay, so what we need to do is we need to have a single variable that can contain multiple values. That's what an array is. We saw before that the type of an array looks like this. With these little square bracket guys. By adding these square bracket guys, we're actually telling the compiler to not just have a string that can contain one value or one bit of text. We're telling it to contain multiple values. So if I wrote a string, names variable, and I instantiated it using the new operator to a new string of 5, that will take too long to draw, a new string of 3, what we've done is names now contains 4 buckets. It could contain 4 string values, or 3 string values, as opposed to just being able to contain 1. And that's because we created an array and we've instantiated it to have 3 slots in it. So names has 3 slots, and each one of these slots can contain their own individual strings. So I can write a string literal right here, S1, and I can shove it in this slot. And I can write an S2 string literal, and I can shove it in this slot. And I can write an S3 variable, that's not even close, S3 variable, and I can shove it in this slot. An array has slots in it that allow us to contain multiple values. So it's kind of like a, well, I mean, think about a post office. Post office has a bunch of slots and they all have addresses to them. So we have, one box, one PO box, and another PO box, and another PO box, and they're all PO boxes. But they have different addresses on them. So this might be PO Box 5, this might be PO Box 10, and this might be PO Box 13. I don't know. It doesn't matter what their addresses are. The point is that if we have a post office, we have an array, which is funny because that's the actual English definition of the word. We could say there's an array of post office boxes in this building, and that would be completely true. Just like, have you ever heard of an array of guns or an array of cannons or something like that? Like an array, an ordered list of individual unique things that we can all refer to as a collection of items. And that's exactly what an array allows us to do. Which is why up here we have 4 variables. I'm going to delete the 4th variable just to make it consistent with my array, because my array, I was lazy and only had it contain 3 values. Okay, so in this case we have 3 distinct variables that can only contain 1 value each. Here we have 1 variable that has 3 slots in it, 3 places where we can put information into it. And the great thing about arrays is that we can access each one of those 3 slots in a dynamic way that isn't possible to do with normal variables. So let's talk about the syntax for accessing an array. So we have our names, and it has 3 slots in it. How would I go about differentiating my slots? Well, I do that with an index. So this slot right here, the first slot in my array is at index 0. My second slot is at index 1, and my third slot is at index 2. Now, some of you who already have programming experience might be coming from languages like Cold Fusion or Visual Basic, where arrays actually start at number 1 as their index. Well, C, C++, C#, Java, and most other languages start arrays at the 0th index, and that's at 0. So we have 3 slots inside of this array. This array contains 3 separate, distinct values. They're all of type string. We know they're all of type string because we told the computer that they're of type string. You can have an array of any type, but They must be homogeneous in that every single item has to be the same type. You can't have a string array and then stuff integers into it. That doesn't make any sense. So what we have right here is that question. I was hoping that question didn't come up, but it did, and I'm going to have to answer it because I probably should have anyway. And that question is, why do arrays start with the 0th index as opposed to the first index? Or why is the first index 0 and not 1, more specifically? And that's just because. It's funny, there's this very specific historical reason why this is. It's because arrays in C and other languages before it were not actually technically arrays, they were just pointers in memory. And 0 was always the first item because that pointer always pointed at the first item. So when you said 0, you meant an offset of 0. You want to walk 0 yards to get to this box because the variable is already pointing at this box. If you wanted to get the first item, you have to take one step forward in order to get that first item. Or sorry, the second item. You'd have to walk one step forward to get to that second item. So yes, we use arrays that start with 0. And that's just how it is. All right, so we have our string and it contains 3 slots, but how do we access these 3 slots? Well, we can do that with the index operator. So if I went ahead and did names, remember, names is the name of the variable. So we have names. We use the index operator, which is square brackets followed by a number to reference a value inside of the array. That's like saying, okay, I want the post office box at this post office with this particular address. We're uniquely identifying the second value inside of this array by placing a 1 inside of square brackets. Now what can we do once we've indexed an array? Well, once we index an array, it turns into whatever item we're pointing at. Meaning I can say names1 equals test. Then I can say write names at 1. At 1. And what do we get printed out? We get test. Oh, that's awful, 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 awful W. That's just as bad. I'm about to give up, I swear. There we go. Sorry, there's a lot of lag with when I have all my recording equipment going on. For some reason, it doesn't like Windows 8 too much, so I get a bunch of lag in Photoshop. But anyway, so what are we doing with this code? Well, we are referencing the names array, and we're doing that because we typed in names. So because we typed in names, we're referencing the variable we called names. I mean, that's just how variables work. Then we are indexing it by specifying in square brackets a number. And that number, in this case, is 1. 1 equals the second item inside of the array, which if we expanded array right here like we did with this diagram, we see that 1 is the second box. Again, an array is just a collection of all these boxes that we can stuff things into. So we can create arrays with a bunch of different sizes. I mean, you know, in theory, we could create an array of infinite size if we had an infinite amount of memory. And we determine how many items are in the array by this number right here. So again, we have a string array which allows us to contain multiple strings, and we can access those multiple strings with numbers. And then again, just to point out that the types, an array is homogeneous in that everything has to be the same type. You cannot stuff an integer into a string array Because when I do names at 2, this is a string. Think about it like this. The type of names is an array. This is an array. Specifically, it's a string array. When I use this operator right here, I'm taking the string array and I'm indexing it to 2, which is the third item inside of the array, and then this entire expression turns into an individual string. So I hope that, I mean, for people who are having difficulty understanding the code before, is the concept of what an array is, what it does, starting to make sense. Not necessarily how you might use one, but the concept that an array is a collection of variables. It's a big bucket that we can then reference each individual bucket by passing in a number using the index operator with these square brackets. As far as examples for when you might use an array, well, there's probably too many to count. I mean, let's say you had a program that tracked inventory for a warehouse. You would want your inventory to be in an array or some other data structure that may or may not be more appropriate in that situation. But the same concept applies. An inventory is a thing, but it contains 0 to many other things. And that's what an array does. An array contains multiple stuff inside of it. In games, you might want to do things like track how many bullets there are on the screen, and you might want to be able to loop through all of the bullets you have on the screen to know if any of your bullets has collided with any of your game objects. Or you might need a collection of, well, enemies. I mean, there might be only just be one player in your game, but you might have 1,000 enemies. How are you going to keep track of that? Are you going to go in and sit there and type in bad guy 1, bad guy 2, and so on and so on? Are you really going to write that code? No. Instead, you're going to write a bad guy array or similar data structure, which we'll talk about. So anytime where you need to access something that may be 0 to many items, you would use an array or a collection. And collections follow the same rules as array for the most part, and we'll talk about the differences during this class. But the point is that the concept of containing multiple values inside of a single variable is incredibly important and is used in all sorts of everything. And when I say all sorts of everything, I pretty much mean all sorts of everything. Look at BuzzNet right now. I know a lot of you guys are in BuzzNet. Do you think there's a limit to how many messages you could type into BuzzNet? There's not. I didn't go through and type in message 1 equals, message 2 equals, message 3. No, I didn't. I have a collection of messages, and I can add as many items as I want to it. Well, eventually you'll bog down the database server, but that's beside the point. Yeah, every single message that you type into BuzzNet is in an array. When I'm looking at the list of all the users who are in BuzzNet, that's in an array. When you look at the top of BuzzNet and you see the classes you've joined, right now the only class that's available is C# 101, but if you had joined multiple classes, that's stored in an array. So, Where would you use an array? You would use an array anytime that you need to store multiple values in the same variable. So let's jump back into the code. I mean, conceptually, is everybody there conceptually? Like, the code's going to look scary, but there's not a whole lot I can do about that without telling people to practice. But conceptually, I hope everybody is on their way to kind of understanding why we might want to use this. All right, so let's jump back into the code and take a look at the syntax. Because no matter what programming thing you're trying to learn, there's always going to be the concepts, and then there's going to be the syntax. And they're both important. They're both necessary to learn, but sometimes the concepts are scary, and sometimes the syntax is scary, and sometimes both are scary. So let's talk about this. We have a name array, which contains 6 strings. We know it contains 6 strings because we told it it contains 6 strings. Then we enter a loop. This while loop loops from 1 to 6. And it will say enter name blah. So it'll say enter name 1, the first iteration, enter name 2, enter name 3, and so on and so on. That should be fairly straightforward. But what gets crazy is this. Again, what I'm doing right here is I'm indexing the array. And look what I'm passing into those brackets. I'm passing in name index -1. And name index -1 hopefully makes sense now that we understand that arrays have zero-based indices, meaning they start at index 0, or the terminology gets very complicated at this point. Technically, the first index of an array is 0. So they start at 0. And unfortunately, our name index, because I wanted to display to the user enter name 1, I didn't want to display to the user enter name 0. Our name index starts at 1. So we have to subtract 1 from our name index to get the right slot inside of our name array to be set to whatever console.readline returns. Then we increment our index. This is a very, very common pattern. In fact, most any time that you'll be playing with an array, you will have something that looks like this. You'll have an index variable. You'll loop until that index variable is a certain value, and at the end of your loop, you'll increment it or decrement it. We'll get into a bit of syntax that makes this a whole lot easier, but for now, I don't want to talk about anything other than arrays at this point, because that's a interesting or a complex subject into itself. So next up, after we've done the array, or the loop, that means our name array now contains all of these values. In fact, I'm going to go ahead and freak everyone out. You guys want something visual? I'll give you something visual, but promise not to scream. Okay, so I'm looking here at my program while it's running. And I'm going to hover over name array and look at what it is. Name array is a string with 6 variable, or a string array with 6 items in it. And if I click on this little plus right here, notice how I have 6 different values inside this one variable, but they're all set to null. Now, we haven't talked about what null is, but suffice to say that null is the default value for what a string is. So let me go ahead and set a breakpoint right here and hit F5 and type in my names. So I'll do name 1, name 2, name 3, name 4, name 5, and name 6. Now I've paused my program again. I paused my program and I'm looking at what my program is exactly doing. If I hover over my name array, now look what it is. We have name 1, name 2, name 3, name 4, name 5, name 6. Those are the things that I typed into the console. Now every single individual little bucket inside of here contains their own unique values. And we can access those values by indexing it. Like, for example, if I tossed open my immediate window right now and I typed in name array at 2, I get name 3. If I type in name array at 0, I get name 1. If I type in name array at 5, I get name 6. Does anybody know what's going to happen if I type in name array and then just toss in a bunch of numbers? Yeah. we'll get to why that is in a moment here once we start talking about collections. But for now, just keep in mind, we can only access name array from 0 to 6, or to 5, sorry. And the reason we can do that is because there are only 6 elements inside of the name array, which are all set to name 1 through name 6. Okay, I'll go ahead and stop the debugger. So, we have a name array, and it contains 6 items. Let's throw together another example. Again, these are academic examples, but I hope people are starting to realize that yes, we are writing a program that you can type in strings and then they come out in reverse order. That's not super exciting. But what if we were, creating an array of projectiles, or an array of enemies, or an array of users in BuzzNet? It's the same concepts, and that's what's important. So let's go ahead and write a simple program that allows us to type in 5 numbers and adds them all up and produces the result. So what I'm going to do, I'm going to start with a number array equals new int. I said 5 numbers, so let's go ahead and do 5. So what's going on here? We are creating an array. We're declaring it with this code right here. We're saying we want a number array of type int array. Again, remember, every time you see these little square brackets right there, it pretty much just means array. We're turning an int into an int array, and that's what we're creating. The second bit of code, we're instantiating the int array to be an int array with 5 elements inside of it. So we have a number array, and that is an array of ints, so it contains 5 ints. So let's go ahead and write code that allows us to fill this array up with values. I'm going to say int number index equals 0. I'm going to do it the other way around this time. You'll see what I mean in a second. While number index is smaller than 5, then console.writeLine number index plus 1. Oops. There we go. So I'm doing it the other way around, where my number index is actually going to be 0 based, but when I present it to the user, I'm going to add 1 to it. So it's the opposite of what I did before. Well, then what I'm going to do is I'm going to say number array. Actually, yeah. I'm just going to use int.parse. Remember, every time you see me use int.parse, you should really always use int.tryparse, but this isn't a tryparse example. This is an array example. So I'm going to keep things as simple as I can. Okay, so now we have code that'll allow us to fill up our number array with 5 integers. And again, we do that by every time we iterate through this loop, we access a different item based off of our number index variable, which gets incremented every time our loop executes. And then we set that value to the result of int.parse console readline, which I hope people have seen a lot of already in the last 2 classes. But this just means that we are going to be parsing out the result of the user typing in text and storing it in an integer and stuffing it in the array. All right, next up, we want to, like I said before, I want to add all of the numbers together that the user typed in. So I'm going to need a variable to store the temporary result in, and I'm going to declare my variable up. That'll crash some stuff. What am I doing wrong? Oh, yeah, it will crash. It'll crash if I don't type in numbers, because I'm not using int.tryparse. And then actually I'm going to use write instead of writeLine, but that's stylistic, doesn't matter, ignore what I just said. So what I'm going to do is I'm going to create a variable up at the top of the method that will store the result of adding all my numbers together. set to 0. And then I'm going to enter a separate while loop that will add them all together. So first of all, I'm going to say number index. I'm going to reset it to 0. While number index is smaller than 5, then what we're going to do is we're going to say addition result plus equals number array at number index. Then we're going to say number index plus equals 1. And then at the end of this program, we'll say the result of adding those numbers is so enter number 1, 1, 2, 3, 4, 5, and the result of adding those numbers is 15. So, yeah. Again, the array allows us to reference, shut up, Wick. I know. But I think I'm destroying everybody's brain enough today. Again, what we're doing here is we have a string array that contains 5, or an integer array that contains 5 buckets. And so maybe this isn't the best whiteboard to bring up because this is all string arrays. But we have an integer array that contains 5 buckets, and we can stuff 5 different integers into it. And we do that by accessing it through the index operator. And again, there is a thing that I did say before as I was writing this code. I did it the other way around that I did before. Instead of having number index start at 1 and go to 5, I have number index starting at 0 and going to 4. That way I can just directly access the number array. But when I present it to the user, I want the user to see it in a 1-based index. All right. So how's everyone doing with the syntax part of it? Everybody seems to be okay with the concepts of what we're doing, but how is the syntax looking? So I'll run over the syntax really quick. Again, we have a type because every variable needs a type. And we have a type here. By adding these little square brackets, we turn an int into an int array. The next thing that we have to know is that with arrays, we must instantiate them. Why do we have to instantiate them? Well, because I told you have to instantiate them. We'll get into more details about what that actually means later. Next week, we're going to be talking about things like the stack and the heap and memory and value types versus reference types and all that fun stuff. But for now, we need to instantiate arrays. That's what we need to know so far. The next bit of an array is this little number inside the square brackets. That just tells the array how many items it can contain. Finally, the only other bit of syntax people need to understand about arrays is how we pull a value out of an array. And we pull it out of an array by using the index operator, which are these square brackets. Again, square brackets are a very common theme with arrays. So we have square brackets with a number index, and that just allows us to retrieve an individual value out of that array. Okay, so I think for now arrays are good, something that people will definitely want to practice. But there is one limitation with an array, one very big limitation. Arrays can only contain X amount of elements, and they can never contain more of those elements, and they can never contain less of those elements, or fewer of those elements. Once you set an array size, it will never change. Let's say I wanted to write a program that allowed the user to type in as many names as they wanted to, and then printed those names out back in reverse order. Well, with an array, what do I put inside of this? Like, what do I put inside the square brackets? How many items do I add in the array? Well, someone might go, well, I'm sure the user will never type in this many names. Let's go ahead and use that. You don't want to do that. What you want to do is you don't want to use arrays, because there's no way to get around the limitation of the fact that once an array is instantiated, it will only ever contain the amount of elements that you told it to contain. So what do we do then? And why did we just spend so much time talking about arrays if I just said that they have such a large limitation that you won't use them very often? Well, what the developers of many languages have done, C++, C#, they've created what are called collections. Collections are just ways to store multiple values inside of something. That's all they are. They're a special type of variable called objects that allow us to store a bunch of different information into them, just like we can do with arrays. The difference is that collections are typically not limited by size. So they'll behave just like arrays, except for you can add and remove items from them. So the whole discussion about arrays that we've just had is still completely valid. This concept is still important, and the syntax will look similar. But what we want to do in C#, when we want to be able to store as many items as we want to use collections. Okay, people are talking about vectors. I'll just say this once. What we're about to see with C# is exactly what you would do in C++ using vectors. It's the same thing. So let's create a collection. Instead of creating a names array that can contain only 5 items, I want to create a names collection that can contain as many items as I want to ever put into it. So let's do that. Okay, the first thing you'll notice about this code is it won't compile. The second thing you'll notice about this code is that I just totally tossed in a new bit of syntax that nobody has seen yet, and you guys are going to blow up. Yeah. So what we have going on right now is, like I said, the first thing, this code does not compile. If I hit F6, look what the error says. It says the type or namespace name list cannot be found. Are you missing a using directive or an assembly reference? Well, fortunately, we're just actually missing a using directive. The using directive that you have to put into your code in order to make this code compile is using System.Collections.Generic. By using System.Collections.Generic, we can now use lists in our code without having to manually specify the namespace every time. Okay, so we have a list. Let's break down the syntax a little bit, because I know this is getting pretty wild. The way you pronounce this bit right here, the way you would say this in English, is you would say list of type string. These are not greater than the less than signs. At least as far as the C# compiler is concerned, they're not. What we're doing is we're specifying a type parameter, or specifying a type argument specifically. And if that just completely doesn't make any sense to you, don't worry. Just take it for granted that a list, like an array, is homogeneous. You may only have, once you create a list of type something, that list may only ever contain that type. Now, not all collections are like that, but lists are. And it's a good thing, because if you have a collection that can contain multiple types, you will get very confused very fast and your code will probably blow up. So again, what we have here is an example of generics. What generics are, how to use them, how to write your own, doesn't matter. The point is that if we want a list of string, we say list, open up this symbol, put in a type, close a symbol. And to pronounce it, again, it's Lisp. Wow. Sorry, I read the chat on accident. List of type string. So that's our variable type, is list of type string. Then we have to instantiate it. Again, why do we have to instantiate it? Because we do. the particular reason why we have to instantiate this will be covered in week 6 once we get into object-oriented programming. But for now, we have to instantiate lists. When we instantiate them, we have to instantiate them to be of the same type that we declared them as. That's why we have to repeat ourselves and say, okay, I want a variable called names, and I want it to be of type string, or sorry, of type list of type string. Then I want to instantiate it. What do I want to instantiate it as? Well, a list of type string. And then we have to put these parentheses right here. Why do we have to put these parentheses right here? Well, because we have to. Again, the particular reasoning behind these parentheses is important and significant, but will be covered in week 6. So, yeah, there is a little bit confusion about what we have here on line 2. What we're doing is we're importing the namespace System.Collections.Generic. And the Systems.Collections.Generic namespace was introduced, so time for a history lesson, everyone, was introduced in .NET 2.0. Before .NET 2.0, there was only System.Collections. System.Collections contained collections, obviously, because it's System.Collections, but it contained collections that didn't enforce the type of the collection. They weren't capable of making sure that we have a collection of a particular type. That was a very poor decision on Microsoft's part, in my opinion, for introducing this language without that support in version 1, but they did. And when version 2 rolled around, they created the System.Collections.Generic Namespace, which contains things like lists. And lists are awesome because we can constrain what kind of type they contain. I can't tell you how many bugs were caused by the original collections that came out with .NET 1 because they didn't require that every type was the same. Zed, you would have to, if you're specifying the namespace on one list, you'll have to specify, or you should specify it on the other side, or add a using. So if I didn't have a using statement here, I would have to say System.Collections.Generic.list, and then over here, I would have to say System.Collections.Generic.list. That's really verbose, and I don't like doing that. So instead of doing that, I'm going to take those off, and I'm going to use a using statement. Alrighty. So now we have a list of names. And that's great, but it brings in some new concerns. First of all, how do we add an item to our list? How do we access items from our list? And how do we know how big our list is? Those 3 questions, once answered, will pretty much give you the roadmap to using lists in pretty much anything that you would want to use them in. And although lists have a lot of functionality that I'm not going to be talking about today, those are the 3 big things. So let's write our names code again. I'm going to say, let's do string or boolean quit, or is running, or how about is entering names equals true. While is entering names is true, I want to say console.write enter a name, or hit enter to stop. Then I'm going to say string input equals console read line. I'm going to say if input equals blank, that means they just hit enter. I'm going to say is entering names and set it to false. Actually, I'm going to invert this statement. There we go. So if the user did not type in or just hit enter, I want to add a new item to my names list. How do we do that? Well, we do names, and then we introduce another new bit of syntax. I know today has been pretty much introducing new syntax left and right, but the new bit of syntax we're going to be talking about is the dot operator. The dot operator, when applied to certain types of variables, or actually all variables, allows us to access a large amount of functionality that is associated with the type of variable we're using. Because names is a list of string, it has a method on it. Whoops, I said method, but it has a bit of functionality on it called add. So what I can do is I can say names dot, the dot is very significant, add. And that says I want to perform the add operation on the names variable. Okay, so add is a method. And it's a method that takes in an argument. The argument it takes in is whatever we want to add to the name list, which in this case is going to be input. So while we are entering names, we prompt the user, we gather input, we check to see if the input is not blank. If it isn't, we add it to our collection. If the input is blank, we exit our while loop. So now we can go on and on and on and keep on typing in names until we're done typing in names. So that's pretty cool. Now let's write the rest of our program. If you guys recall, this program is supposed to get a bunch of names and then print them back out to us in reverse order. So let's do that. First thing I want to do is I want to have an index variable. I want to say int names index equals 0. And I'm going to stick that at the top of my method. Then I'm going to enter a while loop. I'm going to say while names index is smaller than, now this is where things get crazy. You guys ready for this? Names.count. I almost typed in length there because I was still stuck in arrays, but names.count. Again, the dot operator means that we want to do something on the variable to the left of it. And what we're doing is we're retrieving how many items were entered into this collection. Actually, I did things totally backwards right now. Let's back up real fast. We're not going to want to say while names index is smaller than names.count. What we're going to want to do instead, because we want to go through this collection backwards, is we want to set names index to names.count. And then we want to say while names index is greater or equal to 0. Then we're going to do names index minus equals 1. And we're going to say console right line names at names index. And of course I totally failed. There we go. Okay, so what we want to do is we want to retrieve the count of our collection and assign it to a variable. And then we want to loop while this variable is still greater or equal to 0, and we want to print out the result of indexing the names collection based off that index variable. So now when I hit run, I can say Nelson, Lekay, test, test2, test3, whoa, stuff, and things. And then when I hit enter, we get a crash. The reason we get a crash is because I reversed where my decrement happens and I didn't change my equality operator. Whoops. It happens. So we do Nelson, Lekay, test, whoa, stuff, and things, and so on, and hit enter, and check that out. We get the reverse of what we typed in, and we can type in as many of these as we want. So there's 3 things about lists that we need to know. 4 things, actually. We need to know how to instantiate them. We need to know how to create a list variable. Next up, we need to know how to add items to a list. We need to be able to know how many items are in the list. And we need to be able to retrieve items out of the list. So again, that's pretty much all there is about collections. Everything that I've talked about arrays is still valid. this entire concept of having multiple values in a single variable and having those values be accessible through an address called an index is the exact same concept that we're working with lists. The difference is that we can have as many of those values as we want with lists. I would very much encourage people to write out this program. Maybe screen cap it right now, or once it's available for video, just write it out. And the reason I suggest that is because we have a lot of new syntax here that we haven't used before. We have the list type right here where we have to specify a type. We have our property accessors, which again we'll talk about in week 6. We have a method that's attached to an object, which is another weird thing that we'll talk about in week 6. So again, we have a lot of new syntax to look at. But we can now accomplish things that weren't previously possible. We could now have as many names as we want. Remember back when I said BuzzNet uses an array to contain all of the messages? Well, that's true mostly. Arrays in JavaScript aren't fixed size. So there you go. It's not like an array in C# where you have a fixed size. So when I say I'm using an array to contain all of the things in BuzzNet, I'm using an array that has or can hold as many values as you want it to. In C#, those are lists. A list is an array where you can contain as many values as you want. It's not fixed by how you instantiate it. All right, so how's everyone feeling about collections? Alrighty, so what I'm going to do is I'm going to go ahead and go on break. Then when we get back, I want to quickly go through switches. Switches will be a wonderful change in pace for everyone because they're fairly straightforward. We'll jump into for loops, which will be a little bit more complicated, but we'll have a review of them next week. And then we'll take a quick look at for each loops, which are actually fairly simple. So, okay, and we're back. So, we're very quickly running out of time, but fortunately we got through all of the major concepts that I wanted to get through today. The final few things are just little bits of syntax here and there that we can use to make our lives a little easier. The first one we're going to be talking about are switches. Now, switches should be a very simple concept to understand because they're just another way to write an if statement. For example, let's say I had int menu choice. Remember this from homework where we presented the user a menu and we have them enter in a choice? Well, I'm going to take a shortcut right here. I'm just going to say int menu choice equals 4 and ignore the rest of the program because that isn't relevant. The way we had written code before, we would do something like if menu choice equals 1, console writeline choice 1, and then we would do menu choice equals 2, menu choice equals 3, and then we would have to say if the menu choice is not 1, 2, or 3, then say that they've written an invalid choice. This pattern is so common that many languages support the concept of a switch statement. A switch statement is just a compact way to write if statements that look like what I'm looking at right now. So let's look at the syntax. Again, it's just special syntax that allows us to do some fun stuff. So we start off with the word switch. So it's a keyword. We know it's a keyword because it's blue. Then we open up parentheses. Inside the parentheses, we place a expression, such as menu choice, which menu choice is an expression of type integer. Then we open up a block. So you'll notice that this is very similar to how if statements look. This is very similar to how while statements look, and so on and so on. It's a very common pattern in curly brace-based languages. But what goes into a switch statement is very interesting. We have case statements. So I could say case 1 colon console writeline choice 1 break. Case 2 console writeline choice 2 break. Case 3 console writeline choice 3 break and default console write line invalid input break. That's all there is to it. A switch statement is basically just a special form of an if statement. It's not a loop. It's not going to loop over and over and over again. And it looks like this. And there's not a whole lot I can really say about it other than that's what it looks like. We have an expression up here. We always put in an expression into these parentheses. And then we have cases. If any of these cases match this expression, the code underneath the case between the colon and the break will be executed. So if menu choice is 2, only this code executes. The rest of the switch statement is ignored. Finally, there's, so I know this is kind of looking sort of weird maybe to people because we have this concept of a break. Break is a funny keyword because it has 2 contexts. One, it has a context inside of looping, and 2, it has a context inside of switches. They're completely unrelated. All I can say about the existence of the break keyword is this is how you separate cases. So there was a question, do you have to put a break on the default? And the answer is yes. As you'll notice, we'll get an error saying break statement is missing. So again, we have a switch on menu choice where we have different cases. Now there are rules about switches, about what kinds of things can go into them, what kinds of things can't. They get kind of complicated, but the important thing to know about them is that an expression goes into the parentheses and constants that are the same type as the expression go into the cases. For example, I couldn't do this. And honestly, what does that even mean? Case 4.4? I mean, if you guys recall from week 2, 4.4 is a double. A double is not an integer. This code is not allowed because we cannot have a case for a constant that is not the same type as what we are switching on. So we can't have case 4.4, we can't have case blah, and so on and so on. So again, backing up, we have a switch. Switch has an expression. Then we have cases with constants. And you just simply have to take the syntax for granted. There's nothing special or magical about it. It is simply how the case state or switch statement looks based off the specification of the language. There's one more thing to know about switch statements in C#. And that is C# does not support falling through. If I were to remove that break here, we would get an error and say break statement is missing. The only reason I'm saying this is for people who come from other languages where this is actually possible. Next up, we can have multiple case labels for a single expression. Let's say that I wanted to have a case statement for the value 4 and the value 5 and the value 6. I can say console write line, you entered 4, 5, and or 6. This is valid C# code. Now remember, I cannot, if I use this syntax in this way, I cannot put code inside of this. Otherwise, I'll get an error. Break statement is missing. But if I don't have code, I can have multiple case labels be used for a single expression. Well, if I were to run this code right now, what I would get is you entered 4, 5, or 6. The reason I get that is you'll notice that I set my menu choice variable to the value 4. I switch on menu choice. And then if we read through this code, we can see, well, is menu choice 1? No, it's 4. 4 isn't 1. Is 2 4? Nah, 4 isn't 2 either. Is 3 4? Nah, 4 isn't 3 either. Now 4 is 4, which means this code executes. There was one more question about could we have a continue inside of a switch? And what I was saying was before is that people might not understand why this would even make sense to do this, but that's because breaks can also exist inside of loops, and loops can also have something called continues. This break syntax has absolutely 100% nothing to do with looping. So I know it's the same word, it's the exact same keyword, it looks the exact same, you say it the same way, but it is not in any way related to the concept of looping whatsoever. This break is a concept that is owned by a switch, and we know it's owned by a switch because it appears inside of a switch block. So yeah, actually, Wick, I think you can do that. I've never done that, and I wouldn't recommend doing it. I'm not going to talk about what you said, but I actually think you can do it. So yeah, that's a switch. It's a special form of an if statement. Why would you want to use a switch statement? Well, just for syntax. I mean, does this look cleaner than the equivalent if statements? Then use this. That's all I can say about it. The reason we didn't introduce switches when we talked about if statements is because in reality they do very similar things. A switch statement is simply a more specific form of if statements, or a collection of if statements, and that's it. You use them for purely stylistic reasons. All right, so does everybody kind of understand what ifs are? Or sorry, switches, whoops. I encourage people to practice them because any new syntax that you run into will seem very alien when you type it out the first time. Just practice it a few times, get it in your head at least as far as how the syntax works. And if you find yourself in a position where you think in the back of your mind, wait a sec, a switch would actually look kind of nicer than an if statement here, then use it. Just remember, there are lots of limitations to switches. Namely, we can only have constant values inside of our cases. We cannot have expressions. We cannot have case less than 2, for example, and so on. So there are restrictions to how you use them. Okay, let's talk about fors. So we've seen this pattern a lot. Let's go ahead and write a basic while loop that we've seen written quite a few times, break it down into its parts, and see how a for loop makes writing common looping problems very easy. So I'm going to say int index equals 0, not idnex, index. While index is smaller than 10, console write line, we are on index plus equals 1, or index plus plus. So the 2 lines that I have commented underneath index plus plus are the exact same. They do the same thing. There's no difference. Index plus plus is a shorthand form of saying index equals index plus 1. So what's a for loop? Well, we see our while loop right here, and we see it goes, we are on index 0 through index 9. This is so ridiculously, insanely common that the designers of most curly brace languages have introduced the concept of a for loop. Let's break our while loop down into its components. We have our variable initialization. We have our condition. We have our code, the code that we want to run on every iteration of the loop. So let's go ahead and number these. We have variable initialization, we have our condition, we have our code, and we have our action. Which is typically incrementing a variable. So this is our while loop, but we've broken it down into 4 components: variable initialization, condition, code, action. This pattern is so ridiculously insanely common that we have for loops. For loops are a way to write a loop that follows or that just rearranges the order of these 4 components. That's all it does. So let's do that. I'm going to say for int index 2 equals 0, index 2 smaller than 10, index 2 plus plus. Then I'm going to write console write line, we are on index 2. Hit F5 and check that out. Well, let me go ahead and add a add that in right now. We have 2 loops that do the exact same thing. But guess what? This one is a whole lot shorter and easier to understand once you get used to the syntax. So let's break it down. This is number 1. This is number 2. This is number 4. And this is number 3. So what have we done here? We've taken the common aspects of a loop and we've reordered things. For loops simply allow us to take this pattern and write it more concisely. That is all that they do. So let's look at that. Number 1, variable initialization. We usually have to initialize a variable to count how far along we are in the loop. Number 2, condition. We need to know under what condition the loop needs to stop looping. Otherwise, we have an infinite loop. Number 3, code. We need code to execute on every iteration of the loop. Otherwise, there's really no reason to have a loop in the first place. Number 4, action, which is usually incrementing our variable. So with the for loop, what we do instead is we have number 1, which is our variable initialization, followed by a semicolon, followed by our condition, which is number 2, followed by a semicolon, followed by our action, which is number 4. The thing I think that confuses people the most about for loops is the order in which things happen. If you ever have difficulty understanding for loops, you might want to screenshot this actually, honestly. Because if you understand this code is doing the same thing, just in a different order. Number 1 executes once. Our variable initialization of a for loop will only execute once at the beginning of our loop. Our condition, or number 2, will execute just like while loops work, meaning this condition will execute every single time the loop is looped over. Once the condition is false, the loop stops looping. It's the action that I think confuses most people. Number 4 is actually appended to the end of the loop. As we can see up here on line 12, we're doing index plus plus. Well, on the for loop, we're specifying that at the top. But in reality, this code actually gets injected at the bottom of the loop, meaning index 2 is only incremented once our code runs. So then we have our code, which is number 3. And that's the most important aspect of a loop. Again, if you have a loop that doesn't have any code in it, there's no really real reason to have a loop in the first place. So all you do with for loops is it provides a cleaner way to write common looping scenarios. I mean, what if we wanted to write a loop that started at 0 and counted up by 25s until it hits 100? Well, we can write that. For int index 3 equals 0, index 3 is smaller or equal to 100, index 3 plus equals 25. Zero, 25, 50, 75, 100. Again, I really encourage people to write this code out and help them solidify their understanding of the syntax. How's everyone doing with for loops? Because I remember when I was learning programming, for loops were kind of confusing, just because you have to know which parts of them execute at what point. The variable initialization only executes once. The condition executes before each iteration of the loop, and the action executes at the end of the loop. And I think that's the biggest thing that people get confused about, and the biggest thing to understand. But if you ever have any doubt about what you're exactly doing with a for loop, just look at this diagram and match up these numbers with these numbers and see how it relates to a simpler loop, a while loop. Because a while loop is the simplest loop that you can possibly have. The thing with the while loop, though, is they become very verbose when you do common things like incrementing an index variable by 1. Evo, yes. And I would talk about that, but right now I want to jump into for each loops unless there's something that somebody's completely missing with for loops. Show an example of a reverse for loop. Sure. Actually, you know what? This will be on video, so I'll go ahead and delete this. And I'll show an example of looping backwards through a collection. Okay, so we have a basic collection, a list of strings, and it has 4 names in it, 1, 2, 3, and 4. Let's write a for loop that will loop backwards through this collection. So let's say for int I, well, let's just do index. I'll talk about I in a second. For int index equals names.count minus 1. Index is greater or equal to 0. Index minus minus. Console write line names at index. So we have 4, 3, 2, 1. We have successfully looped through this backwards. So how do we do that? Well, again, we just created a list and stuck 4 names into it. That's all we're doing there. Then this bit right here is what's important. Our variable initialization is we're creating an index variable of type integer that's set to names.count minus 1. We want the first iteration of this loop to start with index being 3. Remember, arrays and collections are 0 index based, meaning that names at 0 is 1. Actually, hold on, let me do that. Names at 0 is that. Names at 1 is that, names at 2 is that, and names at 3 is that. That means we want our index to start at 3. Well, unfortunately, names.count is going to return 4 because there are 4 elements in the collection, so we have to subtract 1 from it to get our first index. The next thing we do is we say while index is larger than or equal to 0. So until we get past 0, going backwards, we'll keep on iterating. Finally, we'll decrement our index. What is index minus minus? Well, index minus minus is the same thing as index minus equals 1, which is the same thing as index equals index minus 1. It's all the same code. So, yeah, that's really, that's how we go backwards through a collection. And notice how much cleaner this code is, because all of our looping concerns are all encapsulated here on a single line of code. as opposed to being strewn out with the rest of our code, and it keeps things very isolated so that we can just focus on writing the actual things we want to happen. Okay, there's one more loop to talk about, and it's actually the most complicated thing to explain in C#, most likely. Or one of the most complicated things to explain in C# is how exactly this loop works. The good thing about this loop, however, is it's very easy to use. Don't you love that? How like something that's very easy to use is typically the hardest to explain? I mean, it's pretty much true for most programming. Nah, it's not the most difficult thing to understand in C#, but it gets involved. But we're not going to be talking about how it works. We're just going to be talking about what we can do with it. What if I wanted to print or loop through all of my names and print them all out to the screen? Well, we could say for int index equals 0, index smaller than names count, index plus plus, console right line names at index. Well, that's already a step up from our while loop. Remember our while loop? Our while loop would look something like int while index equals 0, while index is smaller than names.count, console.writeLine names at while index plus plus. So here's how we would write the code in a while loop. Here's how we would write the code with a for loop. But this is so incredibly, ridiculously, insanely common. You will find yourself looping through a collection one item at a time, starting at the first item so many times in programming it isn't even funny. Which is why most programming languages support a dedicated looping construct for doing exactly what we've been doing here. So watch this. For each string name in names, console.writeLine name. Each one of these loops do the exact same thing. So notice the simpler the construct, the more code you have to write. So up here we had a really simple while loop, which is the simplest loop that you could possibly have in any programming language. Then we have a little bit more complicated for loop, but it's actually cleaner once you get used to it. And then we have a super clean and easy for each loop, which is, like I said, if you want to find out how for each loops actually work, it gets very involved and not something we're going to be talking about until probably C# 102. But yeah, the usage of for each loops is very simple. You use the for each keyword followed by this. This contains a variable declaration, the in keyword, and a collection. Could you pop in some green text against together too? I mean, some green text. Yeah, so this is a while loop. This is going to be our for loop, and this is going to be our for each loop. Okay, so we start off with saying the keyword for each. We know it's a keyword because it's blue. We open up parentheses. We then have a variable declaration. In this case, the variable declaration is name. Then we have the in keyword followed by a collection. Now, it could be a collection or an array or even other things, but we won't talk about that. So, yeah. What we're doing here is we're instructing the computer to loop through every single item in the names list and execute line 41 for every single item in the names list. Every time we execute line 41, we want the computer to take the current item we're looking at and shove it into the name variable, meaning the name variable that I declared right here will change every single time the loop is executed. So on the first iteration of the loop, name will equal 1, because that's the first item in our collection. On the second iteration of the loop, name will equal 2. On the third, it'll equal 3. And on the fourth, it'll equal 4. So when I hit F5, we see that it prints out 1, 2, 3, 4, which proves what I just said. So for each loops always starts at the beginning of the collection and will continue sequentially until it reaches the end. Can you easily reverse the order of a for each loop? I so don't want to answer this question. Yes, but not right now. Yeah, I'll show some stuff at the end. Okay, so yeah, a limitation of the for each loop is we do not have indexes. A for each loop will not allow us to have an index knowing which number of the item we're looking at. That's just the limitation of for each. But the good news is that in practical programming, it's not required much. Alrighty, so are there any questions about what we have with our for each loop? It's a simple construct, well, it's a complex construct that we can use very simply, and it lets us write code quicker. Somebody did actually bring up something I completely forgot to talk about. Can anybody tell me what the result of this program is, or specifically this line of code? Come on, does anyone want to guess what's going to happen when I run this code? We get an infinite loop. That's a good answer. Does anybody else want to chime in? We get another infinite loop, and we get an overwrite, and somebody got it. 2 people got it. We got a runtime error called an exception. When you're inside of a for each loop, you may not modify the collection you're looping over. If you want to modify the collection you're looping over, you should use a for loop. Otherwise, you will get an error saying collection was modified, enumeration operation may not execute. There are very specific reasons for this limitation, but it starts to get into the mechanics of a for each loop. Is that just for each loops? Yes. Only for each loops will throw a runtime error if you try to add something to it. So for example, I could do this in my for loop right here. I could say names.add another one, hit F5, and what do we get? Like everybody was saying before, we get an infinite loop. Because every time we run the loop, we add a new item to the list, and then the list never ends, so we get an infinite loop. But with for each loops in particular, it'll throw an exception. Okay, so there is a little bit of confusion about the way I'm using the terminology with lists and collections. In programming, collections are things that you can have that allow you to have many items inside of them. A list is one type of collection. There are many types of collections. One that we'll be playing around with at some point soon is called a dictionary, that allows us to associate a key with a value. So there's a variety of different collections that we have access to, but they all have their own little limitations and use cases and all that fun stuff. Okay, so I think that about wraps everything up. We talked about arrays, which we had a nice little nifty whiteboard session for that. We jumped into collections for a while. We went into switch statements, which again are just a fancy way to write an if statement. We talked about for loops, which are just a fancy way to write a while loop. And we talked about for each loops, which is really just a fancy way to write a for loop. I think that's about it. So what would be really cool for homework, I think, and people might absolutely hate me for suggesting this, but I think it would be a very good exercise to work with some of the stuff that we've been doing today, is to modify your program so that the inventory is actually populated dynamically at the beginning of the program. So what we would have to do is we would have to store our inventory inside of collections, like a list, and then the user would be responsible for entering all the items. So we would do something like, the prompt would look something like, enter item 1's name or blank to stop. And then we would type in Coke. And then it would say, enter item 1's price. And we would type in 43.4. And then it would continue to ask us for items until we typed in a blank name, in which case it would stop. Alrighty, so I think that pretty much wraps up the lecture. However, stick around because we will have a Q&A session for everyone, because there are some questions that I want to answer, but I think that all the future people are pretty much brain dead at this point. So, yeah.